Hi there, in this video we're going to cover section 3.6 rational functions, mainly finding vertical asymptotes, horizontal asymptotes, and end behavior of a rational function. We're also going to talk about slant asymptotes, although I may do that in a separate video. So the graph of this function is shown, and we want to find any vertical asymptotes and horizontal asymptotes of this graph. So first of all, what is a vertical asymptote? What are they? So vertical asymptotes are lines of the form x equals a, right? Vertical lines. So the lines with undefined slope. So a vertical asymptote has that kind of graph. So what is it? So x equals a is a vertical asymptote. And I abbreviate vertical asymptote as VA, right? Vertical asymptote. So x equals a is a vertical asymptote if, as y goes to plus or minus infinity, the x values are approaching a. So that's what that little arrow means. So as y approaches plus or minus infinity, x is approaching the value of a. So let's see. So let's go back up to the graph. So when y goes to positive or negative infinity, so we're seeing here that the y values, right, this one, the y values are going to negative infinity. And same thing here. The y values here are going to negative infinity. So we need to figure out what line is this. So because this is going to be essentially our vertical asymptote. And notice also that here on the left side of it, here y is approaching positive infinity. So this is definitely an asymptote. So what value is that? So if that's 5, so it's 4, 3, 2, 1, 0. Okay, so this looks like the vertical line x equals 2. So x equals 2 appears to be a vertical asymptote. And what else? We notice that y goes to negative infinity here. So that's along, appears to be this line. And notice that y on the left side again is going to positive infinity here. So which vertical line is this? So this appears to be, so there's 0, -1, -2, -3, -4, -5. So this appears to be x equals -2. So these two vertical lines are asymptotes of, are vertical asymptotes of our function. So vertical asymptotes are vertical lines where your y values are going either to positive or negative infinity. Which notice that if we go back to the function here, notice that if you factor the denominator, you get x minus 2 and x plus 2. So here, if you set it equal to 0, right, these are where the function is undefined. So the y values, so y is undefined when x equals 2 or when x equals -2. So this is also our domain, but notice that those are the vertical asymptotes of the function. Now what about what's a horizontal asymptote? And based on the definition above, for vertical asymptotes, it's very similar, but instead of being vertical lines, horizontal asymptotes are going to be, horizontal lines. So horizontal asymptotes are lines of the form. So what does a horizontal line look like? Of the form y equals b. And so we're going to say y equals b is a horizontal asymptote, HA, if y approaches b as x goes towards plus or minus infinity. So the arrow means, so this part says y approaches b as x approaches either positive infinity or negative infinity. And so let's look at our graph again. So here, as x goes to infinity, so that's over here, right? The x values are going to positive infinity. So what are the y values doing? So they're getting close to this line, over here. And notice that as x goes to negative infinity, the y values are getting close to this line. So are they the same line? Yep, and so that is 1, 2. So this is the line y equals 2. The horizontal line, 0 slope, is a horizontal asymptote. So that's what it means to be a horizontal asymptote. So horizontal asymptotes are y equals. They have the form y equals b, and vertical asymptotes have the form x equals, right? A y equals a constant is a horizontal line, x equals a constant is a vertical line. So let's look at an example. So horizontal asymptotes can also be considered the end behavior of a graph. In this case, the end behavior is that they are approaching a number. They're leveling off at a particular value, so that's a horizontal asymptote. But if you look at like y equals x squared, right? If you look at this doesn't have any horizontal asymptotes because this is a parabola. So when we look at the end behavior, as x goes to positive infinity, y is also going to positive infinity. So there's no horizontal asymptote there. As x goes to negative infinity, the y values are going to positive infinity. So there's no horizontal asymptote there. So horizontal asymptote is when the end behavior of a graph is approaching a number. So that would be like your y equals b. So in the particular case up here, our y values as x go to positive and negative infinity are approaching the y value of 2. So that becomes a horizontal asymptote. So let's try another example. So I'm finding the vertical asymptotes and horizontal asymptotes of y equals 1 over x minus 5. Now you may recognize that this looks familiar. This 1 over x minus 5 is a transformation of which function? It's a transformation of y equals 1 over x. So 1 over x looks like the hyperbola like this with a, notice that we have a vertical asymptote at 0, and we also have a horizontal asymptote at 0. So this one has VA at x equals 0, vertical asymptote, and a horizontal asymptote at y equals 0. So this is a transformation of y equals 1 over x. So what does it look like? What is the transformation? And notice that it's essentially the x, we subtracted 5 from the x, so that means that we have a horizontal transformation. So the vertical asymptote, instead of being at 0 as it is here, where is it going to be? The horizontal asymptote is 0 when the denominator is 0, so sorry, the vertical asymptote. So here is going to be whenever x minus 5 is 0. So that means we have a horizontal transformation at 5. So graphing this function will have a vertical asymptote at 5. So I just draw the line x equals 5, but it's always dotted because x can't actually be 5, right? If you put in 5 in there, you're going to get 1 over 0, so you're not going to have a y value there. And then, because it's a transformation, that just means we moved it horizontally to the right 5 units, but the graph itself is going to look like the original parent graph. So we're going to look like 1 over x. And you can find, for accuracy, you could find what the y-intercept would be so that you know where does it come. Does it go up? But it doesn't, right? Because we have a horizontal asymptote still, and that didn't change. So it's still going to have a horizontal asymptote at 0, and then it's going to come into this. You can also use test points to check it out, right? When we have a vertical asymptote, once I know that my vertical asymptote is the line x equals 5, then I can see, okay, what's happening as x gets close to 5 from either side. So say when x is 4.9, what are the y values doing? And so when you plug it in, we're going to have 1 over 4.9 minus 5. And then you can see what this is. 4.9 minus 5 is negative 0.1, so we're going to have negative 0.1 here, and then 1 divided by negative 0.1 is negative 2. So notice that then as x goes to 5 from the left, right, as it gets close 4.9, we're going to be a negative number. So that lets me know, okay, I'm going to be going to negative infinity. You can even try other values like 4.99, 4.999, and it's just going to keep getting smaller, smaller, smaller. What about to the right of 5? So what about over here when x is, say, 5.01? What is the y value? Y is going to be 1 over 5.01 minus 5, right? And my function is 1 over x minus 5. So what do we get? This is going to be y equals 1 over 0.01. And what at 0.01, you can think of it as 100. So 1 over 100 is going to be 100. And so we can say that, okay, that is going to positive infinity. So that fits the criteria for a vertical asymptote. Back to our definition, vertical asymptote is a line of the form x equals a, where x is a vertical asymptote if, as y goes to positive or negative infinity, x approaches a. So, right, as y goes to negative infinity is when we're approaching 5, and y goes to positive infinity as x approaches 5 from the right. So that's how we can find the vertical asymptotes, which I usually think of the vertical asymptotes are what make the denominator 0, because they're the places where the function is going to be undefined. Let's try one more of these for the vertical asymptote. Notice that because this was a transformation of 1 over x, our vertical asymptote switched to x equals 5 instead of y equals 0, right? That was the horizontal transformation, but there was no vertical transformation, so our horizontal asymptote of 0, x equals 0, stayed at x equals 0. So let's try another one. What about y equals 1 over x plus 2 plus 1? So again, this is a transformation of y equals 1 over x. And so remembering, keeping in mind what this graph looks like, right, we have a horizontal asymptote of 0 and a vertical asymptote of 0. So what is the transformation doing? It's moving our horizontal asymptote, but now it's also moving our, it's moving our vertical asymptote here. And now it's also, because we have a vertical shift, it's moving our horizontal asymptote instead of being at 0, like it is here, but this is going to move up 1. So this is a vertical shift of up 1. So that means that this horizontal asymptote is going to move up 1. So it's going to go that way. And we have a horizontal shift. Which way? And this moves to wherever x plus 2 is 0, which means when x is negative 2. So that's going to be now a vertical asymptote. Instead of being at 0, is going to move to negative 2. So let's graph that. So now I'm going to have x equals negative 2 is a vertical asymptote. And we're going to have a horizontal asymptote at 1. I know it's kind of funny, right? Because our vertical shift actually moves our horizontal asymptote, and our horizontal shift moves our vertical asymptote. And so now we have this, and how do I fit my hyperbola, those two curves, in here? Well, you can do it by, to get an accurate graph, find your intercepts. So what is the y-intercept? And are there any x-intercepts? So how do we find y-intercepts? Y-intercepts are when x is 0, so plug in 0 for x. So that means that y is 1 over 0 plus 2, which is 2 plus 1. So 1.5. 3 halves, or 1.5, 1.5. So I'm going to have, so that's 1. So this is going to be my y-intercept. And what about the x-intercepts? X-intercepts are when y is 0. So when y is 0, what's x? This one is not as easy to solve. So I'm going to have, right, my equation is y equals 1 over x plus 2 plus 1. So let y be 0. So substitute 0 for y. We're going to get 0 equals 1 over x plus 2 plus 1. I'm going to subtract the 1 over to the other side. So minus 1 equals 1 over x plus 2. And now you can think of it as almost like cross multiplying or taking reciprocals. So you can say that negative 1 times x plus 2 is equal to 1. Divide by negative 1. And now subtract 2 from both sides. So x equals negative 2 minus 1 is negative 3. So I'm going to have my x-intercept over here at negative 3. And this, just finding the intercepts, is really nice because it allows me to sort of place my graph. And again, you could do some trial and error, some test points. So you can go to the right of negative 2, so you can pick like negative 1.99 and see what is that going to do. But because I already have my y-intercept here, I think it should go to positive infinity. Plus, I know that this is a transformation of this 1 over x graph, so it should go to positive infinity. And then here, this one, along the vertical asymptote goes to negative infinity, so we should be going to negative infinity over here. So there's my x-intercept, and then we go down to negative infinity, and then we get close, oops, we get close to the asymptote here. This graph of my y equals 1 over x doesn't cross the horizontal asymptote, so this one shouldn't either. It's okay to cross a horizontal asymptote, you just can't cross a vertical asymptote. So these are transformations of 1 over x. Now what if we have something a little more involved? So I'm going to do that in the next video. So what we're going to graph in our next video is going to be y equals 4x squared minus 4x all over x squared minus x minus 6. So we're going to find horizontal asymptotes, vertical asymptotes, and we're going to attempt to graph it. So try it on your own to see if you can find horizontal and vertical asymptotes, or at least the vertical asymptotes, and then go on to the next video to see what the solution looks like.